And I think that's the danger of this chapter. I start off with easy stuff that you already somewhat know how to do, though sometimes I worry about that too. And your brain starts going down gear. And then when I hit the hard stuff, your brain is at a down gear and you have to gear it back up. And that's hard to do. So concentrate from beginning to end of this chapter and you'll be fine. You will be. And don't skip classes. This one is not one you want to skip classes. So let's start off with simplistic ideas and then build it up to more complex. Make sure my brain is going in the right direction. There's a part of section 8.1 that I could care less about. They do income taxes. I have done every problem in the book and I still can't get the right answer on income taxes. And you have to worry about that because income taxes are supposed to be able to be done by the general population, right? And I can't do it. I don't know what it is about taxes. They are so weird. Personally, I think they should just do a flat tax and, yeah, sure, tax the heck out of me and take my money, but make sure it's fair across the board. Nobody can do their own taxes. I have a program that does mine. You plug in the numbers, it does all the calculations. Or you take it to a tax person. You're supposed to be able to do it on your own. I wish everybody had the easy form. How much did you make? How much did we deduct? Here's your return. Simple. So I'm going to skip taxes, and I'll just concentrate on what's important in 8.1. So 8.1 is basically percents. Percents. And whether you know this or not, and you're really good at it or not, please pay attention because there's little things in here that I've seen common mistakes with. First off, what is the definition of a percent?
Is that a fraction?
It's a fraction. It's a ratio. What's true about the ratio? It's in the word itself. Per means out of 100. Cent means 100. So out of 100. So when I write something like 17%, 17 is not its value. Remember values from the last chapter? Numbers have values. Numerals are the ones that represent it. Well, this is a numeral that represents a value, but it is not 17. It is literally, by definition, 17 out of 100. That's its value. So when you see a percent sign, that is not its value. A percent is an abbreviation of dividing by 100. So 17 divided by 100, if you do the calculation, becomes 0.17. Do not say to me, move the decimal 2 times this way or 2 times that way, because eventually what will happen is you'll move it 2 times the wrong way. So if you just go by definition, you'll never ever get the wrong answer. If I have 3%, well, that's the same thing as 3 out of 100, better known as 0.03. You won't make any silly mistakes. If I give you 210%, a lot of people say, oh, 210% is impossible. Not if you're talking about like stock value. If your stock value goes up 210%, you're doing really well. Because this becomes 210 divided by 100, better known as 2.1. So 210% has a value of 2 times what you started with if you're talking about stocks. So if you started with $1,000, now you got over $2,000, which is kind of nice. Nice profit. Of course, they tax the heck out of it. The weirder ones are like 3/4%. That's the danger. If you just say 0.75, you change 3/4 to a decimal, but you still have the percent. So this becomes 0.75 of a percent, and by definition, this is 0.75 divided by 100 is equal to...
Can I use my calculator?
I'm giving you an option. We're going to use a calculator all the way through this one.
0.75.
It is not 0.75.
0.0.
How many zeros?
2.
2. 0.075. 3/4% is a very, very small value. It's tiny. If I made this much profit on my stocks, I'd just give up. because it's not worth it. You get a higher percentage just by putting in a 1% savings account. All right, so that's changing percents into its decimal value. Percents into its decimal value. And the important word here, of course, is value. It's how much it's worth, which isn't as much as the percent. All right. Most people get that. This is the danger one. And it's not a danger in the calculation itself. It's the danger of when to do it. When do you do the next one? Which is decimals back into percents. The technique to do it is simplistic. But for this chapter, it's when do you do it? When do I take a value and I change it back into a percent? What kind of numbers are percent values? But the technique is pretty simplistic. If I give you 0.003 and I want to change it into a percent, we just undo what we did over here. To go from 3% to 0.03, we divided by 100. So to go backwards, we're going to multiply by 100. Oh, I should have get rid of 0. 0.003. You're going to multiply it by 100, and that's going to become 0.3. But 0.3 is different than 0.003. So what we're going to put next to it is percent. Therefore, well, I should write it this way. Percent equals 0.003. So the value of 0.003, to convert it to a percent, you multiply it by 100, and it becomes 0.3%, but they have the same value as 0.003.
So I can use my calculator for this whole chapter.
Oh my gosh, yeah.
Isn't there a button for that?
On some calculators, there are buttons for that, but I wouldn't suggest using it because then people use it incorrectly. Especially, well, I mean, there's a button to change percent into decimals, but that's an easy calculation. There is no button to change decimals into percent. What about 2/3? 2/3 has a value. What if I want to change it into a percent? Well, you take 2/3 and you multiply it by 100, but then you have to attach the percent because you're changing the value of the number. The percent brings you back to 2/3. So on your calculator, go 2 divided by 3 times 100. 66 point. Yeah, but what would you write? 66.7. So this would be 66.7%.
What's the other percent for?
This is equal to 2/3. Well, hold on. This is equal to 2/3. This is equal to 200/3. I want the numbers to be equal, so I have to tag on a percent. And then it turns into 66.7%. All of these numbers straight across are equal to one another. They're just written totally different. This is a numeric version of 2/3. It just looks a little weird.
So you just want one number?
One decimal after a percent is usually good for me.
Well, how do you get it from 2/3 to 0.7?
2 divided by 3 times 100.
Okay, I got 66,
66.666666666. I'm just rounding.
Okay.
That's what I mean by that.
Don't use your fraction button. Use divide. Use divide. Because if you
go
go if you use your fraction buttons on 2/3, you're going to end up with something ugly. Yeah, that's but you didn't multiply by 100. Let's say we have 2,050. I have 2,050 and I want to change it to a percent. So the first thing I've ever seen done is people move the decimal point 2 times to the left because they're like, oh, that's too big of a number. But you really have to take 2,050, multiply it by 100, but because you multiplied by 100, you have to change it to a percent. Those two numbers are exactly equal to each other. But 100 times 2,050 is 205,000. But you have to tag on percent. 205,000. 205,000%.
Why wouldn't you put like a decimal in there instead of doing it like that? That's a big percentage.
But that's what it's equal to. This number, 2,050, is equal to 205,000%.
Yeah, because even if you just move the decimal.
Don't worry about how big the value is. The technique has to stay the same all the way throughout. You cannot change what you're doing. All right. Okay, that's good enough for that. So where do we use percents?
So,
Interest.
When you go to the store. When you go to the store, there's something called sales tax. So let's talk about sales tax for a second. Now, we'll do 8th grade style first, and then we'll change 8th grade style into college level type thinking. 8th grade style says this. If the cost of your item is $120 and tax is, let's say, 8%, find total cost. Okay. 8th grade style teaches you to do what?
Change the 8%.
Change the 8%
To a
into a
decimal.
decimal value. So 8 divided by 100 is
0.08.
0.08. So you go 0.08. Leave a little room here to the left because I'm going to do something to the left. Then you take 0.08 and you multiply it by
120.
120. I don't care what that's equal to. I really don't right now. So you do this calculation. What do I do with this number here that I get?
Add it to the 120.
Add it back to the original cost. So 120 plus 0.08 times 120 equals 129.60. This would be how much it costs to walk out of the store with this item. So this part here, this is your tax, and this part here is your original cost. So you take your original cost, you add on your tax, and you get your total amount. Now I teach this in my Math 161 class because it's algebraic in nature. The funny thing is, I ask for tax and sale, and they make both of these minuses. You know, wouldn't it be great to have a tax that takes away from your value of your? Yeah, it'd be really nice, but it's not going to happen. Now that's 8th grade style. Actually, 8th grade style would be find the tax first, get an answer for that, which is $9.60. Take that answer and add it back to the original 120. But that takes too long. So here's the algebra way of saying it. Let's say the cost of this thing is X dollars. Because the price of the item can always change. And then let's leave the tax alone at 8%. So how do I find 8% of X dollars?
Do what you did.
You just do exactly what we did up here. It would be 0.08 times, well up here it was 120, but here
you don't
it's
have anything.
X. So whatever X is equal to, we multiply it by 8%. And then you take that and you add it back to X. Now here's the cool thing. Can I add X plus 0.08X?
Yes.
How?
They got the same variable.
So therefore it's equal to,
X.
no.
So,
Let me, hold on. Let me write something over here first. What's X plus X? 2X. What's 3X plus 4X? 7X. What's 1X plus 0.08X?
1.08.
1.08X. It's 1 plus 8 cents, which would be $1.08. $1.08. So to find the total cost, you only need to do one calculation. You take 1.08 and you times it by the original cost. So try it out. What's 1.08 times 120? The answer better be 129.60.
Okay, but how do we know where 120 came from?
120 came from my original cost up here.
Okay, so just take it from, but
Yeah,
you was
it's
playing
going to be
with
given
X.
to you. Well, X can be anything. I'm just showing that if you use 120, you get the same answer that we had up here.
129.60.
129.60, it has to be. All right, so instead of doing two separate calculations, it's actually better to do the one calculation to get to the final cost. Because how many people worry about, when you look at your receipt, do you see how much you paid in tax? Right? I don't.
I do.
I look at, I worry about how much is it going to cost me? How much is coming out of my
How
checkbook?
much I saved on that day? How much I've saved on that year?
Did they take my discount?
Ah,
Come back next Sunday.
And I might be looking at what's the EBT about.
here's the next thing. Shh. Here's the next one. Discount. Or better known as sale. So you go to the store and things are on sale. Let's say 15% off. 15% off. So you go to the store, everything is 15% off. So let's do it 8th grade style. If my cost is that $120, I go up there with $120 worth of items, and my sale is 15% off, how do I find out how much I pay before tax? Now, you don't set up a proportion. It's easier than that. You take the 0.15. Oh, let me do this in blue. You take the 0.15. You multiply it by 120. What do I do with this number? Subtract it away from the original $120. Now, this is your off. How much is coming off of your price? This is your cost. And when you subtract them, you get your sale price. So what's 120 minus 0.15 times 120? 102? So this thing is going to cost sale price, $102. Yay, how exciting. But again, there's a better way of doing this. Because again, we're doing two calculations. You're doing the 15% of 120, getting an answer for that, and taking it away from 120, that becomes your second operation. So let's see if I do it in one thing. If I can do it in one calculation, this would be awesome. Green marker's done. So let's say it costs my X dollars again, where X can be any cost, any positive number, because it's money. And we're doing 15% off of it. So you do 0.15 times X, and you're going to take that away from X. You're going to take it away from X. So the language becomes X minus 0.15X. Can I add these two together?
Yes.
Yes. What does it become?
1.15.
It's 1 minus 0.15. 0.85. So this becomes 0.85X.
Oh, because you're minusing.
Yeah, because you're minusing. You're subtracting. That's like $1 and you take away 15 cents. All right, now here's the language. Up here, you're taking 15% off of your price. Down here, you're paying 85% of the price. Now, out of the two of them, of is always going to be easier than off. So if it's 15% off, you're going to pay 85% of the price. What if it's 10% off? 90% of the price, 40% off, 60% of the price. It's, they have to add up to 100. So that's a neat little trick. One calculation again. Let's test it out. What's 0.85 times the original price, which was 120? My answer better be 102. Now, there is a way of doing sales tax and sales price all at once, but I don't teach that to you until you're in college algebra. Okay.
What is this?
This is just algebra. Very simplistic algebra. I mean, it's a single variable x. You're adding two numbers together. It's not a big deal. Okay. So, for example, find checkout price in a store with a 30% off everything and 7.5% tax. In other words, your customers are coming to you with items. You first have to take 30% off of everything, and then you have to tax whatever sale price that they have. But I'm going to use these two simple ideas, one calculation ideas each, to get the answer. Otherwise, I'm going to be doing 4 calculations, and I really don't want to do that. So how do I find 30% off of everything? Well, I changed 30% into 70% of. So if I do 70% of, it's going to be 0.70 times, right? 0.70? Or is it 0.07?
It's 0.70.
Are you sure?
Yeah.
Okay, just making sure. Times the original, I didn't tell you what the cost was. Let me give you a number. $230. So it's going to be 70% off of $230 in items or a single item, it doesn't matter. So you put 230 in here.
161.
What is it?
161.
161. This is your sale price. Oh, before I go any further, notice what I've been doing throughout this whole process. I'm giving names to things. The problem with this whole chapter is you're only talking about two different things, percent and money. So you're going to have a lot of percents and monies going throughout your whole problem. If you don't give these percents and money names, you're going to get very confused about which one is which. So if you give them names right from the beginning, you get in the habit and it makes life a lot easier later on. So this is my sales price. What do I want to do with my sale price? Well, I want to find 7.5% tax. Well, when it was 8% tax, it became 1 plus 0.8. 1.08.
Right.
So this is going to become 1.75.
75.
17.5.
They're gonna be 17.5.
What are you talking about?
Ready? 8% becomes 1.08. 08 is 8%. So it
So
becomes
75.
that would be 75%.
1.075.
1.075. So to find 7.5% tax, we're going to go 1 point. How do you write 7.5 as a decimal?
Okay.
0.075. If you have a doubt, take this number and divide it by 100. 0.075. What am I going to multiply it by?
161.
The sale price. So 161. And this becomes more money.
173.
173.
172.
173.7. It's
Which
0.05.
would be 173.08.
It's 0.75.
Zero.
It's
It's
0.075.
It's a
0.8.
$173.08.
8 cents.
Thank you. Couldn't quite hear what you're all saying. Go for it.
Why is there a 1 in front of the .075?
When you do the cost with the tax, when you do this 1x plus 0.08x, you add them together, so there's always going to be that 1 in front. So it'll be 1 plus the tax.
So when you do sales tax, you do that right there.
Anybody ever tell you it's improper to talk while you're yawning?
I started talking first.
Say it again.
So whenever you're looking for sales tax,
It's
you
going
do
to be
the
1 plus the tax.
Okay, and
1
you
plus the
subtract
tax.
when you do what now?
Subtract when you're taking things off.
So it'd be 1 minus tax.
1 minus the percent here. Or 1 minus the percent here. So this one's 1 minus for sale, tax is 1 plus.
Okay.
Okay.
1 minus discount sale and
Right.
tax sales.
Tax is add. Yeah, tax is always add. Where did what come from? Oh, 70? When you take 30% off of everything, you're paying 70% of the price. Which makes it a 1 number calculation rather than splitting it up into 2 different ones. Yeah, that comes from over here. Okay. So that's it. We get $173.08.
Can we do another one of those?
Yeah.
Really?
Really?
Okay.
I know how to do it, but this short one-step stuff is what's confusing me.
Right.
I know.
You go the long way, I have it down pat. But
It
these
just takes you a little bit
short
longer.
Or just like you shouldn't even brought up the long way.
stuff, the short way.
23% off and a 5% 5.4% tax.
How much is
What's it called?
And the cost is $1,099.
low?
You're buying a
I don't know what
50-inch plasma screen TV. I don't know.
$9,000.
So, if we go for the sale price first, what do I do to get the sale price?
$77. I mean 77%.
It's going to be 1 minus 0.23 if you want to think of it long-wise.
No.
Do it the way you just did it.
Which is what I do. It's 1 minus 0.23, which becomes 0.77x. So it's going to become 0.77 times 1,099. Okay. So if you do 0.77 times $1,099.
Okay, we get that one from.
See, that's why you shouldn't have done it.
1
Exactly.
minus
Okay.
0.15.
But you didn't have an X over there.
The problem is when I jumped into 70 here, someone asked me where it came from. So I have to show where it's coming from. It's coming from 1 minus 0.3. Is 0.7.
Miss K, I got a question. Like, we can't just do it the other way.
You can, but here's the problem. When I get going with my other problems, I'm just going to jump to some answers. These will be the simple calculations. And I'm going to skip over how I got to the answer. So showing you how I get there is half the battle.
$846.23.
$846.23. Make sure you put a dollar sign next to it. Make sure you label it as a sale price. This is not your final cost. All right. Next, you want to do tax. Now, how do I do tax? Well, I'm going to take 1 and I'm going to add 0.054 and I'm going to multiply it by whatever the heck value I have. The value I have is 846 and 23 cents. So this becomes 1.054 times $846.23 for a grand total of $891.93. This is your total cost. Yes.
What did 1.05?
Now the 5.4 came from 5.4%. So you go 5.4 divided by 100. That gives you 0.054. Tax is always going to have that 1. This one's 1 plus. Sales is 1 minus. 1 minus a percent for sale prices. 1 plus the percent for total cost. I'm not looking for tax. I'm looking for the whole thing.
So you do your tax, you say whatever the tax is,
You add it on.
divided by 100.
Add it to 1.
So
So it's 1 minus and 1 plus the percent.
that one up there represents 100, whatever.
Yes, 100% of the cost.
Okay, I got
It's
you.
your original cost. 1 represents your original cost.
When we go back 77.3.
All right, what else could we do with percentages?
I'll see you next.
Even when they move to the next.
Percent change.
Oh, that's the end.
That's all I could do is sales and tax, all that fun stuff.
Is this still 8.1?
Yeah, it's still about percentages. Yeah, because 8.2 is simple interest. So percent change is this. Its formula is a little weird. Depends on how you want to write it. I've used different words in place of new and old, but I think new and old makes more sense. New means right now. Old means back then. And old again is back then. Every year, someone from the administration office calls me and says, Mr. Clark, can you help me do this calculation? And I keep telling you'd think they'd write it down, but. And they say, in 2010, there were 3,982 students, full-time students at the college. So they, give me that number. And then they say, and well, last year we ended up with 4,238 students. And they say, well, what is the percent change in the number of students at the school over this 1 year period? So what happens with this formula is this number becomes known as the old number because it was in the past. This number becomes known as the new number, and you just plug it in. It's a real simple calculation. The problem that people have is actually typing it in their calculator, amazingly so. So it goes new minus old, so it's 4,238 minus 3,982 divided by the second number. It's always divided by that second number, which is 3,982. Eventually, we're going to multiply by 100, and then we're going to change it into a percent by doing that.
6.4.
I have to talk about algebra again. Ready? If you have 2 plus 4 divided by 2, do the 2's cancel out and your answer is 4?
Jay, cut it out.
But a lot of people do this. They do this in my algebra class. They want to cancel. And my golden rule is, if there's a plus or a minus, don't do a thing. If there's a plus or a minus, just leave it alone. Now, on a calculator, the best way to do this, if you want to do it kind of like piecemeal, type the top line in, get an answer. Take that answer, divide by the bottom one. Take that answer, multiply by 100. You can, but what do people forget? Parentheses. They forget that this long line means parentheses. If you're going to do it all together, you better put a parentheses here and a parentheses there to get the right answer.
What is that?
I don't know. I have no clue.
So is it 6.43? You want to go with 2 decimals?
Yeah.
When you're dealing with this, did you multiply by 100?
Yeah.
1 decimal.
So
1 decimal.
6.4.
3982 divided by 3982 times 100, 6.4. 6.4. So this turns out to be, after you multiply it by 100, you're going to write 6.4 percent. If you write 6.4, that's actually the wrong answer. You have to tag on a percent, because this value is not 6 times as many students. It's only 6% of increase.
So the
Oh.
answer,
Final answer though is 6.4%. Because it is positive, it's a 6.4% increase. If it's negative, it would be a percent decrease. Don't leave the negative in front of it. Just say percent decrease. For instance,
So we got to put that positive in front of it, that plus. You just put increase.
I just emphasize that it is a positive number. You don't have to put it there.
Just get that in. Already out here, I want you bought it cash money, give me some. What's wrong with you?
I'm just making up numbers. This would be a depreciation for sure. So you start off with new minus old, new minus old, over old. You're eventually going to multiply it by 100, and you're definitely going to change it into a percent. This is one of those ones, if you forget the times 100%, that you have to understand that what you're looking for is a percent, and you change the number at the end into a percent, which is that times 100 and the percent sign. So what's the new?
73.
This is 7,300. It's not the new car, it's my new value, which is 7,300. Minus
15,700.
my 15,700. You also can think my value of my car is decreasing, so that number better be negative, and that's the only way you're going to get it that way. What am I going to divide by? The 15,700, that second number. We're going to take the answer, multiply by 100, and definitely change it into a percent.
0.5 decrease.
Really?
Yeah.
That's horrible.
Oh, wait, yeah.
What is it? 53.5%.
0.5.
Don't forget the percent sign.
Percent decrease.
Decrease.
Okay, so we can either put negative or decrease, right?
I want the word decrease to understand that it's actually going.
But you know it's a decrease.
I know it is, but when you tell someone that my car went negative 35% in price, they'll be like, what? But if you tell them that it was a 53% decrease, they understand what's happening. Your price is going down. Depreciation. What else can we do? I think I beat that one to death. Okay. Woo. All right, that's all of 8-1. So here's 8-2. 8-2 takes about 2 seconds to teach. But it becomes one of the harder things for you to do. I don't know why. Simple interest. Yes, interest. Simple interest. By the way, when you put money into a savings account, they do not give you simple interest for the entire term of your savings. They give you simple interest for 1 month. They'll give you simple interest for 1 month. But then it changes as you go from month to month, and we'll talk about that in the next section. So simple interest has a simple formula. I equals P times R times T. There's a reason I'm spacing it out right now. Because it is a simple formula, guess what happens? People screw it up because they're like, oh, this is easy, and they just throw things at it. You cannot just throw things at a formula. You have to be very precise about what goes where. What does the I represent?
Interest.
Now, when you're dealing with a formula of this nature, you also have to know what kind of numbers are going to go in there. So when you talk about interest, what are we talking about? Are we talking about percent?
Yes.
No.
Interest.
We're talking about money.
We're talking about money. So when you plug in a number here, or you find a number here, it is going to be measured in dollars for us, pounds in Britain, yen in Japan, whatever it's going to be. Euros in Europe. P is called principal. Principal. Principal is also measured in money. It's what you start with. I put $500 into a savings account. So the $500 becomes principal. I borrowed $1,000 from my mom. So the $1,000 becomes principal. Now notice, principal represents borrowing and savings. So it can go one way or the other. Think of it this way. If you put money into the bank, you're saving money, right?
Right.
That's not a good way of explaining. You're saving money, but the money is out of your pocket. So actually it's a negative to you. Who gets the money? The bank. So for the bank, they actually have money. So you can look at it from both sides of the coin of having money or not having money, both being principal. Always. If you're borrowing money, you're holding on to the money, and the other one is waiting for the money. But that money is still called principal from both ends of the perspective, your perspective and the person you borrow from. R is the tricky one.
Rate.
It's called interest rate,
Percentage.
and this one is definitely a percent. When you see the word rate, it's not just a percent. I mean, that's how your brain see it. That's the downfall. It's more than just a percent. Does anybody know of another rate besides talking about money?
Speed.
Speed is measured in what?
Miles.
Miles per hour. So whenever you say the rate, there's always that word per. There's always that word per. So it's percent per what?
100.
No. That's the definition of
200.
percent. No. Think about what it means. When you go to a bank and you say, what is your interest rate here? They will say 5% and then something after it.
1,000.
Banks.
Year.
Something about annual, semi-annually. It gives you a time frame. It's usually called APR. You all have heard of APR, right?
Yeah.
Because it's on credit
Annual
card.
percentage rate.
APR is annual percentage rate. So it's always percent per, what's annual kind of a measurement of?
Year.
Which is a measurement of
Time.
time. So this rate that we're talking about when we say interest rate, it's percent per time. Now, if you have a credit card, do y'all have credit cards?
No.
If you have a credit card and you turn the statement over, they will tell you your percent rate, but it's not APR. They do it per day. They do your interest rate per day. That says 0.0000548% per day. So when you're talking about an interest rate, you have to know what the You have to know what the percent is, but you also have to know what kind of time frame you're talking about. Most common is year, but there are months, there are weeks, there are days. There's a lot of different time frames that can be in there. That becomes of interest, this little time thing down here, because this is also... Now, this is the cool part. If this is percent per time, and I multiply by time, the times should cancel out. So if this is days, this also has to be days. If this is years, this has to be years. So if I give you APR, which is years, and I tell you months over here, you can't cancel them out. But you can change months into years. That's easy. That's an easy
What if we only give
calculation.
us 8 months and 30?
Huh? For example, find simple interest on $350 at 17% APR for 8 months.
What does that say?
8 months.
$50.
Now, if it was 8 years, life would be easy because APR represents annual percentage rate. But because it says 8 months, you have to slow down when you get to the T part of the formula. So the first thing of using a formula, you copy it down. I equals PRT. And you ask yourself all the way across, you don't leave anything off. Do I know I? No. Copy it down. A lot of people just drop it off. If you drop it off, things get a little weird later. So I equals, do I know the principal?
Yes.
Yeah.
$350. So in here, $350. Do I know the interest rate?
Yes.
How do I write it?
0.17.
I have to write its value, which is 0.17. Do I know the time?
No.
Sure, it's 8 months. But I need it to cancel with the per year over here.
So 8 12s?
8 12s. Think of it this way. 6 months is a half a year, and 6 divided by 12 is? A half. Holy cripe. 6 divided by 12 is a half. 12 divided by 6 is 2. If you're talking about a quarter of a year, how many months is that?
No, a quarter of a year?
3. And 3 divided by 12 is 1/4. So if you do 8 divided by 12, that must be how much of a year you have gone through. 8 months out of 12. Multiply this all together and divide your answer by 12. So the amount of interest you earn on this little savings plan, or if you borrowed it,
19 points. 39 points. I got 39 points.
So you times that and divide by 12.
350 times 0.17 times 8 divided by 12.
3 points.
3 point.
I got a grade 6
0, 5, 5, 5, 6.
3 point. Money. This is money.
Oh.
$3
And 30.
and 30 cents.
How you get it? Come on now.
Hold on,
Yeah, I got a bit.
Ready? Calculator illiterate people. 350 times 0.17 times 8 divided by 12 equals 39.67.
Then you said divide that by 12.
No. I said 350 times 0.17 times 8. Take that answer and divide by. You divide by 12 twice.
Yeah, that's what
Don't do that. It's
Okay.
just 1 divided by 12. So it's, I forgot now. $39 and 67 cents. Do not round it to the nearest tenth.
Do not.
It's money. They want every penny available to them. Shine.
Would you mind showing me how you got the 8 over 12 again?
It's 8 months. So what you have to do is you have to convert it into a year. Do you remember unit conversions? If I have 8 months and I want to change it into a year, you would multiply it by a fraction. You'd have months in the bottom and years in the top, right?
Yeah.
How many months are in a year?
12.
And 1 year, right?
Yeah.
The months would cancel, and you're left with 8 over 12.
Oh yeah.
Yeah. Our unit conversions from way back in chapter 1? Chapter 1.
So in simple interest, you're gonna be divided by
Only if it says months. If I said 8 days, it would be 8 over 365. If I said weeks, it would be 8 out of 52. If I said semi-annually, it would be 8 out of
6.
8 semi-annuals would be 8 out of
2. Twice a year.
twice a year.
Oh.
But I would never do that. That's a weird one.
Oh, God.
Okay,
So
now
you just ain't gonna say how many months. You gonna go on into that.
I'll tell you how I gotta give you a time frame. I gotta give you time for most problems. Now here's the problem. If this is how much, if this is how much money he borrowed from his mom, and his mom is charging him 17% interest rate, how much money does he pay his mom back?
$389.67.
You have to take your interest and you have to add on your principal. So there's a neat little formula that said total cost is equal to principal plus interest. So the total cost here would be the $350 plus $39.67 for a grand total of $389.67. So if he had to pay back his mom, this is how much money he has to pay back. My favorite mistake with this is saying, oh, I borrowed $350, how much you have to pay your mom back? Oh, $39.67. Awesome! That'd be great! So you have to use some common sense when you write your answers. Make sure your answer actually makes sense. Alright. There is another formula for simple interest, and it actually comes from this last little piece over here, t equals p plus I. So if I look at it that way, the total value of this loan, savings, whatever it is equal to p plus I. I know something about I. What's I equal to?
Money. Which started.
I equals?
Interest.
I know it equals interest, but formula-wise.
PRT.
PRT. So what I can do is I can replace I with PRT. So I get T equals P plus PRT.
What does the T stand for?
Time.
Time.
She talking about the first two.
Oh, big T, capital T. That means total. Total value at the end. I think the book uses. A.
Can you decide on one of them?
I'll go with the book. A means final amount. I like F.
That's what I was going to say.
F is better because it says future. Future value.
Can we use F? A?
Use A. A's in the book. I like F, but that's just me. Now, is there a way of simplifying this expression?
Yeah.
How?
Cancel the P.
I could take a P. It's in both of them, right? It's kind of combining them.
Squared. 2 divided by.
Y'all took Math 70, right?
Yeah.
What does it say?
6 years ago.
No, you can't add them together. They're unlike terms in the sense of RT.
Divide.
No, you do not divide by the variable you're trying to solve for. Do you remember?
Put P on the outside.
Go back to this.
1 plus RT.
Go back to this. This was.
What is that?
This is tax, 5% tax, and you
I didn't
go.
say that. Why are you looking at me?
I don't know. I didn't hear who said it. So you took your x's,
What is it? 2P.
and it became 1.05x. You took the two numbers in front and you added them together.
Yeah.
The two numbers in front here is
2.
1
So
and
1
here
plus
is
RT.
RT. So if I add it together, you get P times.
RT.
Oh.
2PRT?
RT.
RT.
I ain't got time.
Oh,
RT.
1
Just stay over there.
plus
Oh, RT.
RT.
Oh.
What? What?
Okay, let's do it a different way. Ready? Do you remember algebra?
No.
Do you remember the word factor?
Yes.
If I factor out a P in here, it comes out front. P divided by P is,
1.
and PRT divided by P is,
RT.
and if you multiply it back out, if you distribute it back out, you get P times 1 is,
P.
and P times RT is.
PRT.
It's like pulling teeth. So this is another formula for simple interest. This is still simple interest, SI. SI. But this one tells you something a little bit different than the first one. The first one just calculates out how much interest you owe. This one will find your final or total amount. Total amount. It includes interest and principal automatically. It finds out your total amount. So if we do the same calculation as that problem over there, we would say, well, I don't know my total amount. My principal for my loan was $350.
You stay to the right and go, but I showed you, please.
Ugh, I'm left-handed. Then you go 1 plus. R is 17%, so that'd be 0.17. Time is still the same thing, which is that 8 over 12 thingamajiggy. And you type this into your calculator in one fell swoop. So you go, ready? Calculator people will pay attention, then you don't like these things. You write in your calculator, 350, parentheses. You have to type in this parentheses. 1 plus 0.17 times 8 divided by 12, hit equals. It's right up above the 7.
So it's time.
It better be the same answer as way over there. It should be 389.67.
That's what I got.
And that's what your right answer is.
Total amount.
Because it should be the exact same answer as this one.
Yeah.
Identical.
Can we do it that way?
You can do it that way, but there's one problem with that way.
Oh, okay.
This way, you can solve for I, you can solve for P, you can solve for R, you can solve for T. But if I give you the total amount and the principal and the time, and I ask you to find the rate, that formula doesn't help you. I'm sorry, if I give you the, let me go through all the possible problems. We'll find the one.
Stick to the basics.
There's one that you need that formula for.
What is that?
But you might ask for that.
Because I don't just ask for I or the total amount. There's other things I can ask for. For example, George pawned his gold watch for $500. After 40 days and 40 nights, he paid $600 to get it back. What is the interest rate?
After 40 days.
After 40 days and 40 nights.
Isn't that a movie?
Yeah, I don't know. Sinbad or something like that. Okay, now you have a choice of formulas. You can use I equals PRT, or you can use that one, A equals P parentheses 1 plus RT. For the most part, I would say lean towards I equals PRT. It causes the least amount of mistakes, except for one problem. If I use I equals PRT here, since it is simple interest, it's generally the first formula I would try, and if it doesn't work, go to the other one. Do I know I?
No.
And I'm going to stand here for a while until you give me my answer.
Yes.
Oh.
Yeah, $600.
Nope.
$100.
$100.
Oh, yeah.
Why? Because I borrowed $500 and I paid back. Anything above and beyond how much I borrow is going to be considered interest. So it's $100 of interest. What was my principal?
$500.
$500. What's my interest rate?
We don't know.
We don't
No
know.
clue. What's my time frame?
40 days.
So do I write 40?
40 over 365.
40 over 365. Because there are 365 days in a year. Funny story, banks use 360. Why would they use 360?
Better on them.
More money for them. Because you're dividing by a smaller number, that increases the amount of interest.
So you say 500.
Now, hold on. We're solving for a variable here, so I'm not even touching my calculator.
Wow.
Because I'm solving for a variable.
You need to get it by itself.
I need to get R by itself, so what do I need to move?
Those two.
The 500 and...
40 or 55.
Now, because this is all multiplication, I can use the commutative property and switch the R and the 40 over 365, right? Just so your eyes can see this right.
Yeah.
Some people, for some reason, don't see it the way I do. So here's 40 over 365. I like the R last because that's what I'm solving for. So what can I do to all that junk in front of R? Multiply it. So 500 times 40, what's that, like 2,000? 2,000 divided by 365. 20,000 divided by 3. I would just type it all in my calculator.
About
anyways.
365.
Now here's an important thing.
54.7.
5479.
What do I write down? 54.79? Do I stop
So would
there?
it be?
Or do I write more decimals?
I stopped.
Or do I round to the nearest tenth? Or do I round to the nearest whole?
What do we do, Mr. Taylor?
Well, here's the thing. If you round it to the nearest whole, your answer is going to be way off. Because it's going to have a lot of what's called rounding error. So if you're doing this type of calculation and you're solving for R, 4 decimal places. Keep 4 decimal places to keep your answer reasonable. So what's 500 times 40 divided by 365 to 4 decimal places?
54.7945.
54.7945 times R. Times R.
No, that's fine.
How do you solve for R? You divide both sides by?
100.
Oh, how did I know someone would say that? 100 is nowhere near R. You divide by the number next to R. 54.7945. Divide it to both sides. You always concentrate on where the variable is, not where the number is. So you get R is equal to,
How many decimal places?
this is 3 decimal places. 4 if you want. 1.825. This is the tricky part.
182.5%.
You have to understand to change it into a percent. You have to go, oh, wait a minute, R is a percent. How do I change this to a percent?
Move to the right.
Ugh. You weren't here for my argument. Times 100.
I was here for that part.
Don't be moving things. So this becomes 182.5, and don't forget the percent.
Right.
This is actually a low interest.
And you still get the same.
I know, but here's the thing. I hate when people move because they generally sometimes move it the wrong way because there's a left and a right. I like doing things perfect all the time. So this is actually a very low interest rate for pawn shops. Pawn shops average 300 to 500% interest rate. 300 to 500% interest rate. They have to advertise it. Usually when you sign your little slip, it's in little fine print on the very, very bottom that's really hard for me to read because my eyes are going bad. But they have to advertise it. It's just most people don't even look. Do you remember those check and go places?
Yes.
The original ones, not the new
They
ones.
got a lot
The original ones.
Who?
They got closed down for a specific reason. You'd go in there with a check. You'd say, well, my next paycheck is going to be $500. And they'd say, okay, we'll give you, we'll talk about this in a second. We'll give you your $500, but we're going to charge you up front $100 or something silly like that. Maybe only like 25. You know, something simple like people are like, oh, that's not that much money. But the percentages turned out to be like 1,400% interest rate. 1,400% interest rate. So they'd borrow money, they'd get their check, they'd pay it back, but they'd lose a chunk of it. And then they'd be behind on their next paycheck, so guess what they have to do the next week? Go back again. And it became they were just running out of money. They could never ever pay back the check and go price. So they closed them down, they're illegal. Now they have checking places, but you have to go in there with your check and they'll cash it for you, that type of place. How much time do I have?
Oh.
part of what I'm trying to show you is how to work with formulas, how to go about working with them, how to interpret what goes into them, and how to interpret the answers you get out of them. So, say we have this problem. Paul paid back $1,000. That's not how much he borrowed, that's how much he had to pay back. The answer to this is going to be a little ugly, but a little bit. He borrowed it for 7 months. He borrowed it at 25% APR. I need to know how much he actually borrowed. He probably forgot. You know, I forget how much I borrowed once in a while. So I try to start with this formula. So you go I equals PRT. I'm thinking, oh, this is simple interest. I can use this formula. The problem is this. Do I know how much interest he paid on this loan? No. So you'd leave that alone. Do I know how much he borrowed?
No.
I'd leave that alone. Do I know the interest rate? Sure, 0.25. Do I know the time? Sure.
7/12.
7/12. Why is this a problem for me? I got 2 variables. I need to have this down to 1 to be able to solve for it. So I can't use this formula. It doesn't work. Because there's no way I'm going to find I, and there's no way I'm going to find P. So that's not going to work. So I got to try the other one. And the other one is A equals P parentheses 1 plus RT. I'm going to make 2 formulas at once. That's the simple interest formula to find the final amount. Now if I ask the same questions, do I know A?
Yes.
Yeah, what is it?
1,000.
It's 1,000. Do I know P?
No.
No, leave it alone. 1 plus, do I know R?
Yes.
0.25. Do I know T?
Yes.
Yeah, it's 7/12. How many variables do I have left?
1.
Just 1. I can solve this one. So where I couldn't use I equals PRT, now I can use this formula. This formula only comes in handy if you don't know your original principle. If you don't know your original principle. All right, so how do I solve for P? Do all this junk, get a value for it. A single value. So 1 plus 0.25, 1 plus 0.25 times 7 divided by 12.
1.1458.
1.1458.
Question.
Yeah.
Can we use this one at all times if we want to?
Yeah, go right ahead.
Okay.
I'm just saying, in this case, you have to use it. You have no options. So it's P times, what was it,
1.1458.
1.1458. All right, how do you solve for P? And please don't say divide by 1,000.
No, that's
Divide by that ugly number is probably the best description. 1.1458 divided to both sides, so it cancels out on the right. And we'll find a principal. It's not going to be pretty, but
$872.75.
$72.75. So when he borrowed the money, this is how much money he borrowed, and then he turned around and he paid back 1,000. How would you find interest?
Subtract.
You take your amount and you subtract the principal. So the interest that he paid on this was 1,000 minus 872.75, better known as
$124.25. Excuse me.
Mr. Caloran.